as digital graffiti. And the idea here was I'd have a mobile application, and as I walked around, I could see physical structures that were tagged electronically with different media. And then that evolved into a mobile social AR application where instead of physical structures, I could look at people, and that would present me with different layers of metadata about that individual. Well, as we continued evolving this idea, that led us into actually taking it off a mobile handset and reworking it a little bit to think about what could we do to make it even more ubiquitous. And so with that in mind, we looked at using computer vision to serve up, to recognize people and then serve up still these layers of metadata about individuals. And once we had that idea, it allowed us to explore the problem space a little bit more with how we would expose this data, how we would not only use the computer vision, but how does that even work, because none of us have any experience with it. How do you tie all these different pieces together? And so to get a handle on things, we put together a pretty detailed project plan that allowed us to break the problem down into a little bit more usable pieces, and to understand kind of the scope of the 3 weeks of work that we had. And I think key to this was we had 3 milestones that allowed us to stay on track. So briefly, at first we just needed our system to recognize a face and display a name. And then we built on that to actually recognize a person. And then third was kind of the end-to-end test. So in parallel, we're trying to figure out how do we expose all this information, right? Because we looked for examples of this being done online. We hadn't found any. We've found lots of examples of computer vision and recognizing a person, but not anywhere the system was trying to recognize attributes of a person. And so we started with this, and this has a lot of flaws that I think are pretty obvious. So we tried to see how we could clean up this data and think about how do we visualize information in this context. And so we started playing around with color to try and reinforce the depth, and different shapes. And you see we're still around the head. And then we decided to try a different way to clean that up and use color more distinctly to ID different people. And then different, we can see that we're playing with different shapes here. And this is kind of a halo, can't really see. That's a little more clear. And then we hit upon this idea of using clouds. And I think for the team, this was kind of a key moment, because it gave us a hook that we could then kind of tie everything together. And so we played around between these kind of opaque clouds and then clouds with an alpha value, and having different sized words or a text cloud also to visualize the attributes of the person. And this also gave us ways to think about the motion of the information around the screen. And we felt like it just was a nice metaphor for us to proceed with. We also experimented with these little halos, but in the end they felt too out of control. So that was the visualization part. and because it's not an ideal world, we have this intake part where we ask people to manually enter in their attributes. And so again, we tied in with the cloud, and these questions, we came up with 64 questions that are randomly presented for each person that signs in. And you answer the questions, and then there's a training phase where the system looks at you for 5 seconds, and you move your head like this, and it's mathematically mapping your face for our system to detect later on. And now Victor and Marcus are going to take us through a working demo of it and go into more technical detail about what's happening.
Yeah. Mainly there are actually 3 different programs which are connected to each other in some way. So the first application is the one that Alan mentioned here. It's the where you write in the information and it creates a database, XML file from your face, and also it sends the information that you add to a other database, so it can be read later on. The second application is an application that actually does the recognition. Like you send it a picture and it will answer. It will look in the database that is created and answer with which person that actually is on the image.
And that program is using OpenCV, which is a library for computer vision. Made in C++, and the reason for main reason for dividing the recognition application with the third application, which is presenting the image later, is because the OpenCV is made in C++, and we're not that good at C++, so we couldn't really make anything good visualize-wise. So that's why we have separated it into different applications.
So Marcus has just been scanned by the system.
Yeah, I think we should do one more. So
and now Victor's going to answer the questions. And these questions, we thought a lot about how to evoke different emotional responses. So we had a range of questions that aren't personal at all to questions that might feel invasive in a way. But that was intentional because one of the things we wanted to explore with this was what effect that has in a public space. So here, the idea is that we have that training video. So a person looking at it knows roughly what rate to move their face, so our system can get a good scan. And now we will turn on the projector. I think one of the interesting things that will be nice to observe with a bunch of people, that aren't necessarily tied to this class so intimately, will be how people do respond to seeing bits and pieces of personal information about themselves and about other people. So it takes a minute. Can you move the cursor? Can you move the cursor?
Yep.
There you go. So it's recognized Marcus, and now it's projecting his name and then selecting 2 attributes to show around him. And he could actually back up